Okay, welcome to 4.3, Solving Equations Literally. And this is a practice understanding task, and at first they're going to ask us to solve each of the following equations for x. So let's take a look at number 1. This is your typical algebraic equation. And if we're going to solve for this x right here, we're going to have to isolate it. So you need to think about how can you manipulate both sides of this equation to get the x all by itself. Well, do you see that the quantity 3x plus 2 is being divided by 5? The first thing we're going to need to do is undo that division. So let's multiply both sides by 5. And then you just rewrite the equation. And remember, whatever you do to one side of the equation, you always do the same thing to the other side when you're solving. So on the left, those factors of 5s now would cancel because multiplication undoes division. And then you're left with 3x plus 2 equals 7 times 5, 35. Now we need to get rid of the addition. So what undoes adding 2? That's right, let's subtract 2 and rewrite both sides. So we have on the left 3x plus 2 minus 2 is 3x. And on the right we have 35 minus 2 is 33. And now we have one more step. This is 3 times x. We're trying to isolate the x. So what can we do to undo multiplication by 3? That's right, we'll divide both sides by 3. So the 3's cancel on the left, and we now have x equals 33 divided by 3, which is 11. And that's how we solve our typical algebraic equation. Now, did you notice the title, Solving Equations Literally? Guess what? There's more than one variable in this equation for number 2. That's called a literal equation. But we're still being asked to solve for x. So we're going to do the same process. We're going to isolate the x. Okay, so our first step will be the same. We're going to undo division by 5. Let's multiply both sides by 5 equals, and on the left those 5's cancel, leaving us 3x plus 2y equals the 35. All right, now we're isolating the x. We better get rid of those 2 y's. So just subtract 2y from both sides equals, so 3x plus 2y minus 2y is just 3x. And over here on the right, 35 minus 2y, those are not like terms, so we cannot combine them. So we have to write it out, expanded the way we see it. 35 minus 2y. You can only combine like terms. Okay? And now, just like over here, divide by 3. And your 3's cancel on the left, so x equals, and I would write this exactly the way I see it. That is what x equals. 35 minus 2y divided by 3. So in a typical equation in one variable, you're going to solve for your variable and get a number. But in a literal equation, when you solve for a variable, you're going to get an expression in terms of the other variables in the equation. All right, number 3. 4x over 3 minus 5 equals 11. Well, we better get rid of that minus 5 right there. Let's add 5 to both sides. That leaves us, well, 4x over 3 minus 5 plus 5 is 4x over 3. And then on the right, 11 plus 5 is 16. Now, that x is being multiplied by 4 and divided by 3. That's like multiplying by the fraction 4/3. To undo multiplication by a fraction, you simply multiply both sides of the equation by the reciprocal of that fraction. So 4 over 3, what's the reciprocal? 3 over 4. Now, I hope you see why we did that. Now, on the left, my factors of 4 would cancel, and my factors of 3, leaving x. And on the right, well, 16 times 3/4. What's 3/4 of 16? Now, if you don't see it, just look. Does 4 go into 16? Yeah, 4 goes into 16 4 times, and 4 times 3 is 12. so x equals 12. Now we have a literal equation for number 4, but we're still solving for x. So first step is let's get rid of the negative 5y by adding 5y. So we have 4x over 3 again, but this time on the right we have 11 plus 5y. We cannot combine those. Now we have to undo this multiplication by 4 over 3. So we're going to multiply by the reciprocal again, times 3 over 4 on both sides. And now remember, on the right we have 2 terms, so we need that in parentheses when we multiply by the 3/4. Equals. Now on the left we can cancel common factors. The 4's cancel and the 3's cancel, leaving x. And on the right you could distribute the 3/4 to both terms, but that's probably not going to make this any prettier, so I think I would just write this 3/4 times the quantity 5y plus 11. Call it good. Again, in a literal equation here, when we solve for x, in this case we have x in terms of y. All right, number 5, solve for x. Well, here we'd better get rid of that multiplication by 2/5 first. So let's multiply both sides by the reciprocal of 2/5, 5 over 2, and rewrite. Factors cancel, leaving you the quantity x plus 3. And over here, well, 6 times 5/2. Does 2 go into 6? Yes, it does. How many times? 3. So that's just going to be 3 times 5, 15. And now let's subtract 3 from both sides. So x plus 3 minus 3 is x, and x equals 15 minus 3. That would be a 12. X equals 12. Okay, for number 6, we have a literal equation again. We'll go through the same process, except our final answer will not be a number. X will be written in terms of y. So let's undo the multiplication by 2 over 5 by multiplying both sides by 5 over 2. Cancel common factors, leaving you the quantity x plus y. And again, same thing on the right. 2 goes into 6 3 times, and 3 times 5 is 15. Now one more step, subtract y. So x equals 15 minus y. Those are not like terms. You cannot combine them. You have to leave it just like that. Number 7. Well, let's see. Whoa. We have parentheses in here, and we have x's on both sides. Very cool. Well, because we have x's on both sides this time, the first thing we'd better do is distribute that 2 to both terms on the left. Yeah, I'm just not going to divide, or I could divide by 2 right now, I guess, as the first step. So either way, let's see. I'll bet you I divided both sides by 2. I did. Now look at this. Equals, and the 2's cancel, leaving me the quantity 3x plus 4. And over here on the right, we have 2 terms divided by 1 term, so let's divide each separately. So I'm going to have the sum of, and the first term would be 4x divided by 2. That would be 2 x's. And the second term would be 12 divided by 2. That's a 6. Now let's go ahead and get our x's on the same side. So I have 3 x's on the left and 2 x's on the right. I think I'm going to subtract the 2 x's. Equals, and 3x minus 2x is x, plus 4 more. And 2x minus 2x is gone, leaving me the 6. And now one more step. Let's subtract 4 from both sides. So we have x plus 4 minus 4 is x. That's what we wanted. And what does x equal? 6 minus 4. Now you can combine those. 6 minus 4 is 2. Now the literal equation, we're not going to get x equals a number. We're going to get x in terms of y. So let's do the same thing. Let's divide both sides by the 2. And the factors of 2 cancel on the left. So I have 3x plus 4y. And on the right, I have 2 terms over 1 term. So I'm going to have the sum of, And the first term is going to be 4x divided by 2. That would be 2x's. And the second term is going to be 12y divided by 2. That would be 6y. I hope you all see that. Now, well, we're solving for x, so we have to get our x's on the same side. We have 3 x's on the left, we have 2 x's on the right, so let's subtract those 2 x's from both sides of the equation. So 3x minus 2x is x plus 4y, and then 2x minus 2x is gone, but this time I'm left with not 6, but 6 y's. Now let's subtract the 4 y's. We're going to undo adding 4y. Equals, so x plus 4y minus 4y is x, and here these are like terms. We can combine them. What is 6y minus 4y? Well, that'd be 2 y's. And there you go, x in terms of y. All right, number 9. Write a verbal description for each step of the equation solving process used to solve the following equations for x. Your description should include statements about how you know what to do next. For example, you might write, first I did blank because blank. All right, so they're asking us to do the same thing. We're solving a literal equation here for x, but they want us to explain what we did and why we did it. Okay? Easy enough. Well, if I'm going to get this x all by itself, first I'd better get rid of that minus d. Yeah, that's a literal equation. So let's add d to both sides. And what would that leave me? On the left, I have the quantity ax plus b divided by c. And on the right, I have e plus d. Or you could write that d plus e. Either way. I like alphabetical order, but it doesn't matter. Now, if you're going to isolate this x, we have to undo this division by c. So let's multiply both sides by c. Oh, I forgot. I better describe what I did and why. So first, I added d, the plus d, to eliminate that minus d on the left. Note, it's gone. All right, now, let's get rid of division by c to eliminate that divisor of c. And notice the two terms over here, I put them in parentheses because I've got to multiply the whole side by c. Equals, and on the left, those common factors of c would now cancel. You have one in the numerator and one in the denominator, leaving ax plus b. And on the right, you could distribute that c right now or just write it the way you see it. I just wrote it and I put my factor outside on the left, so c times the quantity d plus e. And again, you could distribute or we can do that later. Now, I'm still solving for this x, so see the plus. Oh, I've got to describe what I did. And what did I do? I multiplied both sides by c. Then I multiplied both by c to eliminate the divisor on c of c on the left. All right? You're always eliminating on the side where the variable you're looking to solve is. All right, now we better get rid of that plus b. How about we subtract b from both sides? So what do I have here? ax plus b minus b is just a times x. And it looks like over here I'm going to go ahead and distribute the c right now. So I'm going to go c times the d. And then I'm going to go c times the e. This is the distributive property. And then I have that minus b. Now none of these are like terms, so I cannot combine them. All right, but what did I do there? I subtracted b from both sides to eliminate the plus b on the left. Then I subtracted b to eliminate the b on the left. I also distributed the c on the right. Cool. Now, well, we've got to undo multiplication by a, so let's divide both sides by a. And now my factors of a on the left will cancel. And then on the right, can I do anything there? I'm going to leave this just like that. CD plus CE minus B over A. There you go. So let's describe what we did. Didn't we just divide both sides by a to get rid of the factor of a on the left? So then I divided by a to isolate the x all by itself. All right, number 10. Well, if we're going to solve for the x, do you guys see how that square root or radical symbol is being multiplied by r? We better get rid of that multiplication by r first. So I divided both sides by r. Now let's rewrite. So the factors of r now cancel, leaving me the square root of mx over n plus s. And on the right, what do I have? That t divided by the r. Okay, so let's describe what we did. And what did we do? We divided both sides by r to get rid of the factor of r on the left. First, I divided by r to eliminate the factor of r on the left. Look at that. All right. Well, if I'm going to isolate this x, I now better get rid of the square root symbol. And what undoes a square root? We square something, so we're going to square both sides. If I square a square root, I can just drop it, leaving me mx over n plus s. And on the right now, I've got to square the t over r. So t over r squared. Okay. Now, describe what we did. And what did we do? We just squared both sides of the equation to get rid of the square root. Then I squared both sides to get rid of the radical on the left. A square root symbol is called a radical or a root symbol. Now, well, we better subtract s to get rid of that plus s. So on the left, I have mx over n plus s minus s is mx over n. And on the right, I have that t over r squared minus the s. I cannot combine those. Okay. Now, well, this x is being multiplied by m and divided by n. And that's the same as multiplying by the fraction m over n. How do we undo multiplication by a fraction? Oh, before I do that, though, we better describe what we did. And all we did on the third step was subtract s to eliminate the positive s or the plus s on the left. So then I subtracted s to eliminate the s on the left. Okay, now I'm going to get rid of this multiplication by m over n by multiplying by the reciprocal n over m. And because I have two terms over here on the right, I've got to put that in brackets to group it, so I multiply both terms. Okay, so what do we have here? Well, I have factors that are going to cancel, leaving me x, and that is what I wanted. And this, I'm going to leave alone. I might bring that n times m over to the left-hand side of the bracket. Okay. No, I didn't. I left it where it was. So x equals t over r squared minus s, that quantity, times n divided by m. And what did we do? We multiplied both sides by n over m to undo multiplying by the fraction m over n. Let's see how I wrote that. Then I multiplied by n over m. Okay, keep it simple. Oh, that is it already. So, again, go through this video, make sure you understand what every step was and why we did it, and welcome to solving literal equations. You guys make sure you get your ready, set, go for, what was this? 4.3, right? 4.3 complete. And have a great day.